Today I'm excited to present how I would teach grade 6 natural sciences of planet Earth and beyond, while making use of a model solar system. The focus will be on two targeted concepts: the Sun, planets and asteroids, and the movements of the Earth and planets. The model serves as an engaging and interactive tool to help learners visualize, understand these foundational topics. Let's start with the Sun, planets and asteroids. At the center of this model is the Sun, which is not only the largest object in the solar system, but also the gravitational anchor. Using this model, I would emphasize the Sun's critical role in providing light and energy to sustain life on Earth, while also keeping all the other planets in their orbit. Next, we move to the planets, represented in their correct order from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. By showing the learners the varying sizes and distances of the planets, I can explain the distinction between inner rocky planets and outer gas giants. For instance, I'd highlight Mercury's small size and proximity to the Sun compared to Jupiter's massive size and its location far beyond the asteroid belt. Speaking of the asteroid belt, the model allows me to illustrate its position between Mars and Jupiter. I would explain that asteroids are rocky remnants of early formation of the solar system, providing a real-world example of how space contains more than just planets. These small, irregularly shaped objects add depth to learners' understanding of the solar system's diversity.
Once learners grasp the structure of the solar system, I would transition to the second concept, the movement of the Earth and planets. Using the model, I can demonstrate the two key movements of the Earth, one being rotation and the other being revolution. First, by spinning the Earth on its axis, I would explain how this creates night and day. I'd emphasize that one full rotation equals 24 hours, and next I'd tilt the Earth slightly on its axis and move it around the Sun to show how its revolution causes the seasons, highlighting the importance of the axial tilt in determining different weather patterns. Expanding this to the other planets, I'd use the model to show that each planet orbits the Sun at different speeds. Mercury, being the closest to the Sun, has the shortest orbit and fastest year, while Neptune, being the furthest away from the Sun, takes over 165 years to completely orbit the Sun once. This visual representation helps learners understand how distance from the Sun affects a planet's orbital period. Finally, I'd connect the movements of planets to gravity. The model is a great way to show how the Sun's gravitational pull keeps the planets in orbit while allowing them to rotate on their own axes. In conclusion, the model transforms the abstract into the tangible, allowing learners to see, touch, and manipulate the solar system. It provides a clear, visual way to explain the structure of the solar system and the complex movement of Earth and the other planets. This hands-on approach not only fosters understanding, but also sparks curiosity about space and science. Thank you for this opportunity to share how we can use interactive teaching tools to make the wonders of our solar system come alive for learners.